Alexander Evgenievich Fersman. Journeys for Stone. Part 2. Listen to the rest of this story on our channel. Also on our channel, you will find many other stories about expeditions and discoveries. Please subscribe and like our videos so that other people can know about them. Thank you very much. On the gem mines. I first visited these places in 1912. I was met at the station by my comrades from the Mineralogical Museum, members of the expedition of the Academy of Sciences, who had already arrived here. In a beautiful school dacha, located on the slope of Ilmanskaya mountain above the station. Our expedition was accommodated here. We brought the rich preparations of the day. Behind the school, on a rocky cliff, there were lonely outcrops of yellow cancronite, a beautiful stone with a greasy sheen, which was sometimes cut into cabochons for small jewelry. Lake Ilmen stretched out below, and the bright spring sun played merrily on its surface. After the tiring railway journey, I looked as if fascinated by this small, always cold mountain lake, lost between the spurs of the wooded slopes of the granite mountains and framed by a dark forest. At the bottom of it they searched in vain for gold and precious stones. But all the hopes for these discoveries of the engineer M.P. Melnikov, who worked here for several years in the 80s, extracting beautiful mineral stuffs from the mines for the Museum of the Mining Institute in St. Petersburg, turned out to be unfounded. Behind the lake, the smoke of a fire slowly rises from behind the forest. These are prospectors mining gold, washing granite, dressing in unpretentiously arranged screens and washers. Along the gullies and ravines of the granite mountains, and rare pieces of gold sparkle in the ladle, along with a heavy magnetic slip and grains of pink garnet and brown zircon. To the east, beyond the lake, the great Chebarkul road winds, once the famous Siberian highway, and it leads past the same old mines, where for the first time the happiness of finding gems smiled on the Cossack Prutov. But the main mines are hidden from us by the wooded ledges of the Ilmensky Range, cut by the railway line. We were accompanied to the mines by Andrei Lobachev, one of the last descendants of those glorious Steiger workers who at the end of the Zvier century became addicted to stone and passed on their knowledge and experience from generation to generation. Lobachev knew the Ilmen forest, knew every pit and every spruce. He knew how to lead to any mine in such a way as to drive closer to it and not get into the swampy swamp of meadows. With the assistance of this peculiar gloomy man, who selflessly loved the Ilmen forest and knew all its secrets, our expedition worked for several years. In vain were the attempts to breathe a cheerful spirit into this man, who at times had a period of heavy drinking, and then there was no longer our Andrei, always neat, diligent and kind. This illness was a heavy cross for him. The forest authorities stubbornly denied him the right to extract stone, and only stealthily, secretly, now on a summer night, now in winter, he rummaged through the heaps of mines, with rare knowledge and skill, looking for essonite and monazite, and even the rarest cryolite. It is difficult to say how he defined stones, how he became acquainted with scientific terms. But Lobachev was not mistaken by touch, by taste, by tooth. He checked his definitions and many times precipitated the newcomers, who gave superficial incorrect definitions on the fly to the Ilmen curiosities he knew well. In the morning, Lobachev served the box, a cozy Ural braided line with shivers, and we drove to the mines with the comfort that you want or not, but you had to get used to it. In the Urals, it was considered shameful to walk a lot, and you were certainly driven to the mine itself, even if for this you had to shake out your whole soul, or even once or twice, turn you out of the braided fabric on a stump or roots. The mines are only for 6 kilometers from the station. At first, the path goes between the lake and the railway, then along the bed of the Cheronshenka River, then along the Ilmensky swamp with peat mining to a gently sloping wooded hill on the slopes of Kosaya Gora. To the right, near the railroad track, there are a few fragments of stone. And, to your surprise, Lobachev explains that this is a former mine of Amazonian stone. Here, for the first time, around 1783, the famous explorer of the Urals I.F. German found an Amazonian stone. The stone shone in the sun, and its color was so beautiful that an order was given to get it for the Yekaterinburg lapidary factory and to carve vases from the best varieties. Later, in 1831 to 1832, when the order of the Almighty Count L. Ray Perovsky to extract 25 poods of the best blue spar came from St. Petersburg, a whole expedition was sent to this mine. Indeed, individual blocks of this stone were beautiful here, now blue with tones of the best turquoise, now greenish with a yellow and grey pattern of sea foam. But now there is nothing left of the past. The construction of the second track of the Siberian Railway destroyed all the remnants of the past, and buried the once famous mine under it. Further on, there are still small digs. These are the mines of Sveen and Helvinden. One after another, in a motley change of minerals, there are mines. How much was previously associated with this word mine, and how often they are negligible or even completely inconspicuous. A pile of stones, the remains of some pit, sodded and overgrown with forest, that's all. Only some mines of the Ilmen Mountains, in which hundreds of workers worked for many decades, are deep pits, sometimes littered with debris, sometimes filled with water, surrounded by huge dumps. In hard granite and granitognous, the work was not easy, and with great difficulty the workers dug pits here, deepened the workings. We stopped at the mines of M.I. Strizov. I have never seen a more beautiful picture, and although I had seen many deposits of colored stones before in the sunny south, on the island of Elbe, in gloomy Sweden, in the Altai, in Transbaikalia, in Mongolia, in the Sion Mountains, nowhere did I feel such a deep sense of admiration for the richness and beauty of nature as in these Amazonite mines. The eye could not tear itself away from the blue heaps of beautiful spar. Everything around was covered with sharp-angled fragments of this stone, which glittered in the sun and shimmered with their smallest perthite growths, standing out sharply against the green background of foliage and grass. I could not conceal my admiration for this richness, and I could not help but recall Quenstedt's somewhat fantastic story, that a quarry in the Ilmen Mountains had been laid in a single crystal of Amazonian spar. The beauty of these mines was not only Amazonite itself with its beautiful blue-green tone, but also the combination of Amazonite with light grayish smoky quartz, which naturally seems to germinate feldspar in certain directions, creating a bizarre pattern. This is either a small pattern reminiscent of Hebrew writing, or large gray hieroglyphs on a blue background. This unusual stone was admired by travelers and explorers of the 18th century, and beautiful tabletops were prepared from it, which still decorate the halls of the Hermitage. These drawings are diverse and original, and you involuntarily try to read in them some unknown to us writings of nature. Here, for the first time, on the heaps of the Strizovskaya mine, I had the idea of studying this riddle, and for the first time, playing with stones in my hand. I began to look closely at these growths of grey quartz, which, like fish, cut through the blue Amazonites, and to look for the laws of their form and accretion. Now these laws have been found. One of the little secrets of nature has been revealed, but how many more new patterns do these mysterious hieroglyphs of the earth draw for us? They speak of the time when powerful granite veins, pegmatites, poured out through the granitogneisses of the slanting mountain and crystallized from the semi-molten masses of the Amazonian stone cluster. At a temperature of about 800 C, this process began, and, slowly cooling, giant crystals of feldspar grew along with smoky quartz. Up to 575 C, The regular pattern of fine written granite was drawn by the smoky quartz that fell out with it. But below this temperature, the gray fishes of quartz scatter randomly. They stretch out larger and larger, disturbing the general correct picture and ending in the free cavity of the vein with smoky heads. There is no surer sign of finding a rich gem than to follow a vein with an Amazonian stone. Outside of it, there are no precious stones. Through long experience, miners have learned to value this stone highly as the best sign for finding a heavyweight. They know well that the thicker the color of amazonite, the more hope that the vein will bring great happiness. The topaz aquamarine veins of the Ilmen Mountains stretch from east to west. They sometimes narrow into a narrow crack, several centimeters wide, then widen, swelling to 2 to 3 meters. Only a few heavyweight topazes sit inside the vein itself. These are raw, large fractured crystals, surrounded on all sides by quartz or feldspar, brittle and unsuitable for cutting. Good stones are located in voids, which are called nests here. Not knowing the beautiful term of the Middle Urals, borough. The size of these nests is up to 1 meter. They are lined with small crystals of albite, Amazonian stone, quartz, mica. These cavities are completely filled with grayish and yellowish clay. Topazes either lie on the surface of the clay together with flat, like lentils, crystals of phenakite and rare black ilmenitol, or lie freely inside the clay itself, which bears the local name lard, and indeed, it is very reminiscent of lard hardened in the air. Topaz crystals in the Ilmen Mountains are colorless and watery transparent, but their purity is beautiful. No less beautiful, but rare, are the aquamarines of the Ilmen mines, either dark green, of the thick color of the Black Sea in stormy weather, as Ayvazovsky depicts it, or light green beryls with the golden tint of the south. But the beautiful stones of the Ilmen Mountains were rare. And now you can admire individual crystals preserved in large state museums, only as a great museum rarity. From the past to the future, the history of the exploration of the Ilmen Mountains is not complicated. The main role here belongs not to the VI century, but to the first half of the 6th century. And this is not surprising, since in Catherine's time the Bashkir Urals were too restless a country. Here, for a long time, it was possible to mine gems only with military guards. The heyday in the history of the Ilmen Mountains began only in the 30s of the 6th century, with the arrival of the Uzbek merchant Menge, who in 1825 began to extract rare minerals here after him. The so-called state-owned colored parties began to work here. The mining department sent here individual expeditions, either mining engineers, lovers of stone, or talented steigers, connoisseurs of colored stone, but all worked without any plan or program. New mines were discovered. The most valuable scientific material was discovered. Museums were replenished with beautiful crystals, which were demonstrated at ceremonial meetings of the St. Petersburg Mineralogical Society. But the mines were quickly filled with dumps of old booty, and other expeditions on colored stone began to work on them again. There has never been a proper mining here, and there has never been an attempt to approach these mines from the point of view of a broad organization of state, or at least industrial business. The Mining Institute in St. Petersburg and the Academy of Sciences, with their weak material resources, could not help the cause. There was a real state predation. Occasionally, the forestry department issued tickets to steigers and workers for the right to inspect and wash the dumps, but they were not allowed to make real mining. Then they stopped giving these tickets. They were afraid of forest fires and theft of forests. A real predation developed, ruining the mines. Meanwhile, legends were created around Mias about fabulous riches buried in the depths of the mines, about rare crystals hidden in dumps, about rich deposits of gems at the bottom of Lake Ilmen. The legend attracted local residents to mysterious mines. Having failed to obtain a legal ticket, stone enthusiasts rummaged through the dumps at night, the old miners Lobachev, Kovalev, Bardin and others, with particular caution, on dark nights. They sometimes tried to break strong fir trees with a pickaxe or go deep into old mines. They did a lot of work and almost completely extracted crystals of zircons, topazes, phenicites from the dumps. The only private person who worked intelligently and systematically in the mines was the Polish stone connoisseur Szyszkowski, who lived for a long time in Mias and mined minerals, mainly for mineralogical collections. He also partially cleared and prepared some mines for visiting the Ilmen Mountains by members of the International Geological Congress in 1897. Academician A.P. Khibiny, the future president of the USSR Academy of Sciences, led this excursion and, fascinated by the richness of the Ilmen Mountains, famous geologists from all countries returned to their homeland, spreading the fame of this natural museum of mineral wealth throughout the world. In the years before the First World War, the Ural Society of Natural History tried to organize the extraction of materials for educational collections here, but these attempts were not made in any serious way. In the first quarter of the last century, the Yekaterinburg, now Sverdlovsk lapidary factory was interested in the Ilmen mines, and quite widely mined beautiful blue-green Amazonite here both for itself and for the Peterhof factory, but then abandoned this production. Before the First World War, an expedition of the Academy of Sciences began to work here, but its tasks were narrow, purely research. Even then it was clear that it was necessary to seriously study the Ilmen Mountains, study their riches, describe the past of this wonderful corner of the Russian land and unravel the laws of the origin of its minerals. The expedition of the Academy of Sciences brought together enthusiasts of the Ilmen Mountains. Among them was the forester of the local cordon, the young student L.A. Kulik, who was sent from Kazan to the Urals, later a well-known specialist in meteorites, and Professor V.I. Kryzanovsky, a connoisseur of the Ural stone, later the director of the Khibiny Geological Museum, and others. But the inspirer of all the work of the expedition was academician V.I. Vernadsky, who visited the southern Urals more than once in search of new minerals. I remember how one fine summer evening we gathered on the balcony of a school in Mias and dreamed about the future. This was at the very beginning of the First World War, in the years of severe Tsarist reaction and bureaucratic arbitrariness. I remember how I told my comrades in the expedition, I am drawing the distant future of Ilmen in a slightly fantastic form. There, at the top of the Ilmen mountain, far from dust and anxiety, there is a cultural resort in a wonderful pine forest. A jagged lift road leads to the top of the mountain from the railway station. Powerful developments of pegmatite veins with feldspar and nepheline prepare material for the large-scale ceramic industry concentrated in Mias and Chebarkal. Below, on the shore of the lake, on the site of the old forest cordon, there is a natural history station, the Center for Managing the Mines of the Ilmen Mountains, the Center for the Protection of its Riches, the base for scientific expeditions and student excursions, with a museum, a library, laboratories. In a number of mines, deep exploration and systematic extraction of Amazonian stone, brown hyacinth, blue sapphire and blue sodalite were carried out. A number of deep boreholes were drilled, cutting through the Kasaya mountain and illuminating the internal structure and distribution of veins. I said that this is, of course, a picture of the distant future, but it must be fought for, because it is necessary for science, for industry, for culture and progress. There is no need to fear that the beauty of the Ilmen Mountains with their savagery, and at the same time friendliness, will be lost, the beauty of the whole, from which the abandoned mines with dumps in which the hitmen dig, and the bad mountain roads, and the wicker on the shivers, and the simple fire with a kettle on a fragment of blue Amazonite are inseparable. In the deep life combination of all these trifles, the present is created. It contains not only poetry, the beauty of untouched virgin land, but also a great incentive to work, creativity, to the struggle for mastering nature and its secrets. I said this when the work of scientific research was taking place in a difficult struggle, when our expedition stopped in abandoned, dirty, dilapidated villages, when a pair of Ural horses could hardly pull boxes through the impassable mud of roads that had never been repaired, when the gendarmerie department, despite the request of the president of the Academy of Sciences himself, refused permission to conduct research near the railway line. Every evening the clang of chains was heard in the transit point located below, under our school, and every evening more and more batches of shackled prisoners were replaced, and the World War was already raging around. The accumulated cultural values were being destroyed, and the struggle for the new was growing. And this new came sooner than we thought. Many of the fantasies of that memorable evening on the slopes of Ilmenskaya mountain are now coming true. Dreams of the past have become a thing of the present. The Ilmensky State Reserve became a real fact, and another conquest of life replaced the former youthful dreams. Here is the difficult year of 1920, memorable to many. There is still a struggle for the power of the Soviets' transport. All means of transportation have been destroyed. Entire regions have been devastated after military occupation, and the White Guard bands are still raging. In March 1918, V.I. Lenin appealed to the Academy of Sciences, urging it to take upon itself the leadership and work of raising and studying the productive forces of individual regions, in order to provide the necessary raw materials for the reviving industry as soon as possible. In these years of titanic struggle, Vladimir Ilyich found time to listen to and discuss the seemingly completely untimely project submitted to the Council of People's Commissars by the Mining Department of the Supreme Council of the National Economy to create the world's first reserve of mineral wealth in the southern Urals near the Maya station. And on May 14, 1920, V.I. Lenin signed this remarkable document, which, in this epoch of the struggle for raw materials, strengthened the greatest idea of the protection of the mineral resources, and contributed to the reasonable and full use of the country's productive forces. Thus, the genius of Vladimir Ilyich created the world's first reserve of the Earth's bowels, the Ilmensk-Waya Reserve, now named after V.I. Lenin. 2 kilometers from the Maya station, there are elegant houses of the reserve administration, its museum and library. This is the starting place for all scientific and educational excursions, the center of complex work on the study of the riches of Ilmen. Almost all the mines have been put in order, cleared of old debris. Every vein has been brought to light by a careful and attentive hand, and rare crystals have been preserved in the walls of the horses in their primeval beauty, untouched by the barbarous hand of an inexperienced geologist or mineralogist. Each mine is fraught with its own curiosities. The riches of the Ilmen Mountains are infinitely diverse, in which there are more than 100 different mineral species. Muzinka's gems. We are accustomed to consider the Urals a treasury of mineral wealth and gems. We are well aware of various jewelry made of Ural gems, but we know little about the conditions for the location of these stones and the nature of their extraction in the Ural Mountains. I had the opportunity to visit the Urals many times and visit countless deposits, including the main deposits of semi-precious and colored stones on the eastern slope, from Verkhochery in the north to the Kyrgyz steppes in the south. But here I will tell you only about those famous, classic deposits in mineralogy, which are usually designated by the name of Muzinka and which I visited in the period from 1912 to 1922. For the mineralogist, this word is associated with the idea of untold riches, and there is no collector either here or abroad who would not appreciate especially beautiful pieces of feldspar, smoky quartz, topaz and other minerals of this deposit. It is difficult to name another corner of the globe in the whole world where a greater number of the most valuable gems would be concentrated than in the famous Mazinka. This region of the Urals reserved for mineralogists. Usually, when looking at semi-precious stones, beautiful topazes, aquamarines and amethysts, ideas arise about the mountainous, rocky areas in which they are mined. But these ideas are completely inapplicable to Mazinka. Here we see a soft, slightly undulating landscape, wide valleys of slow-flowing rivers with real Russian floodplains, vast grain fields, the remains of forests on the slopes of the valley, and only in the south, in the region of the Aduya River, do we enter a wilder, but equally flat country with boundless forests, badly damaged by fires, with dense thickets in the swampy lowlands. Nothing disturbs this smooth and peaceful picture, and only to lonely picturesque cliffs, as witnesses and remnants of former mountain ranges, stand on the banks of the Aduya and Reza rivers. The most picturesque of them is the Shaitan Stone, more than 500 meters above sea level. It rises beautifully above the Rez, and its granite mass all permeated with veins, squeezed into vertically placed folds and layers, reminds of the mountain ranges that once existed on the site of this plain, and of the colossal chemical processes that this piece of land once experienced. In the distant Carboniferous and Permian eras, the village of Merzinskoye itself lies 120 kilometers north of Sverdlovsk, far from the railways, on a quiet tributary of the Irtysh, the Neva River. But Mazinka is a collective concept. In the Urals it included the whole region of the Middle Urals, stretching along the eastern slopes for almost 75 kilometers, starting from the forest wilderness of the tributaries of the Tagil with it. With this fabulous Mazinka, in the Urals is associated with a good heavyweight of blue water and golden topaz, or a beautiful amethyst, which lights up in the evening with bloody fire. In the Urals, it indiscriminately refers to all the best that its nature gives. The old miner Sergei Chrysanthrovich Yuzhikov told me many times, in his cramped hut in his native village of Yuzhikova, everything is in Mazinka, and if something is missing, it means that they have not yet finished it. And he, this passionate miner and lover of stone, believed in his luck that by thin veins, conductors, and by signs, he would get to the very lean with cold soap, topaz and heavyweight. He believed that he would also find the gemstone, that the peasant Danila Zverev had been washing in the sands of Polozikar for many years, and that in a large burrow the gems will be thicker than the sea and a cubit long. I saw many wonderful hobbies and many bitter disappointments during the years of my wanderings, in the wilds of the Urals, and many times, on quiet evenings over the Neva, after the end of the day's excursion, we listened to stories about how in the old days we lived happily, how the stone was all gems, clean and with heads. And in this quiet atmosphere, I remembered the pictures of the past. The beginning of the Old Believers' Mazinka was laid back in 1640, where in the last years of the old regime stood a separate building of the Volust government. A small fortress was once built to protect the large Vukochary highway from the south. It was one of the oldest settlements in the Urals. Located high in the form of a jail, the building is surrounded by a row of logs, vertically dug into the ground on a promontory between the deep valley of the Neva River and the Anbarka River flowing into it from the right. From this region of the foothills of the Urals, imperceptibly turning into the Siberian plain, prospectors have long brought fragments of colored stones. As early as the end of the Zvi century, when our mining business was born in the era of Peter the Great, and when relations with rich Siberia were established through the Great Vukochary Highway, prospectors sent in different directions reported to the Vukochary voivode about the discovery of amethyst and heavyweight near the Muzinsky prison. On the bank of the Neva River, famous prospectors of ores and patterned stone, the Tumashev brothers, went here from Vukochary. In 1668, Mikhailo Tumashev found colored stones and copper ore near the Muzinsky prison, which he announced in Moscow in the Siberian Prikaz. Apparently, this discovery made a great impression, since Tumashev was given a reward of 164 rubles and a half, and an important decree was sent to Tobolsk, in fact, the first decree on mountain freedom, according to which it was ordered to give permission to people of any rank throughout Siberia to search for both colored stones and all kinds of ores without oppressing the inhabitants. The very next year, Mikhail's brother, Dmitry, initiated the smelting of pig iron on the Neva and, having found a number of stones, went to Moscow, about which we find the following historical document. From the Tsar and Grand Duke Alexei Mikhailovich, the autocrat of all great and small Russia, to the Siberian cities, to our stolniks and voivodes and clerks and all kinds of clerks. The smelter Dmitry Tumashev struck his forehead to our great sovereign of copper ore, and said, he went to Siberia to look for ores and found colored stones. In the mountains there were white crystals, cherry fatties, and green and yellow tumpers, and that we, the great sovereign, should order him to let him go from Moscow to Siberia to Verkhoturye for a genuine mine, gold and silver and copper ores and all colored patterned stones, on his own roads, and he should travel freely in the Tobolsk and Verkhoturye districts. Already at the beginning of this century, a small mining industry was born here, which reached its heyday at the end of the same century. This is how the first colored stones of the Mersin region were discovered. Gradually, with the growth of the village of Muzinki itself, interest in them began to increase. Not far away, the first plant in the Urals began to be built, Neviansky 1703. By the 30s of this century, a local craft was created here. It is not surprising that in 1735, upon arrival in Yekaterinburg VI, Genin reported to Anna Ioannovna that in the Murtsinskaya Sloboda, a white yellowish and blackish tumpers, which is better than Bohemian crystal and consists of such a fortress that it cuts glass, and two curious black tumpases were found between them. Muzinka was growing. One of our travelers, Gemelin S.R., in 1740 already counted in Muzinka for houses near the church and 16 peasant huts. In his famous work Journey Through Siberia he gives a description of precious stones. Stones with clarity and simplicity characteristic of naturalists. No less interesting are the reports of Brigadier Beer, the former head of the Tula factories, who, on behalf of Empress Elizabeth, was supposed to travel around the Urals and Altai and establish the extraction and processing of stones 1744. Here is what he wrote in his report. Arriving in the village of Kornilov in the place where those tumper stones were obtained, I saw several hundred dug pits or dug pits 2 and 3 arshins deep. These were the first steps in the history of the use of Russian precious stones. The period of intensified mining continued at the beginning of the 19th century, when the hard labor of exiles and serfs carried out enormous work. Veins of hard granite were excavated over a considerable distance and to a great depth. Here, at the end of this century, pink and cherry red tourmaline was found, which was called Siberite for insane money, for hundreds and thousands of rubles. Individual crystals of this beautiful stone, which was then in fashion abroad, especially in Paris, were sold. In 1768, blood-red amethysts, blue heavyweights, and bright green beryls were discovered. The area of finds began to expand more and more, and the fame of the Mersin stone spread far beyond the borders of our motherland. A great impetus to the search and discoveries was given by the Dannenberg expedition of 1765, sent by I. Betsky to organize stone mining in the Urals. The participants of this expedition were 2 Tartary brothers, natives of Italy, who brought from their homeland both knowledge of stone and love for it. Probably, It is not without reason that one of the amethyst pits near Mazinka was called Taliana, and the crystals themselves are sometimes still called Talioshki. We learn about this expedition from two archival extracts. In the first document we read, "Sent to inspect the previously found and search again in the Orenburg province, and in the Yekaterinburg department of marmor, agate, crystal and other types of colored stones. Major General Yakov Dannenberg." In advance, the reconnaissance and search of the mentioned stones was carried out through various people, sent from the office of Her Imperial Majesty during the passages only, and couriers were sent in the first case due to the lack of skillful ones, as well as Putilov's masons for breaking and working, who know little about this, which is why not only all the benefit, but also sufficient news has not yet been received, and since these hidden stones serve for the benefit of the state and society, Her Imperial Majesty has deigned to order you to be sent with craftsmen ordered from Italy, to be carried out. In the second document, dated April 1767, we find a summary of the results of the expedition. On March 15, 1765, Your Imperial Majesty's Imperial Majesty, on the 15th day of his confirmation, Major General and Chevalier Dannenberg were sent to Yekaterinburg and Orenburg for the investigation and actual development of marmor, agate and other types of colored stones. With a team of 157 searchers in 157 places, the list received from him with the plan and touchstones was presented to Your Majesty. Then more than 200 known places this spring and the coming summer were examined, where it would be useful to develop them, and 1107 finished fireplaces, columns and other marmors were brought, and not a few will be sent this spring. The said Major General imagines that two Russian masters discharged from Italy are diligently teaching, and many of them are showing good success. But this time of flowering of mining is irretrievably gone. Neither the treasury, nor the lapidary factory in Yekaterinburg, nor the handicraft processing and cutting of semi-precious stones that developed in the Urals could support mining. The fishery slowly faded away, and only when you drive through this entire region, when forests stretch for many kilometers, completely dug up with pits and kapushkas, or when you stand in front of some huge mines, such as the Mora pit near Shaitanka, you can appreciate the colossal work and energy that has been invested in the extraction of colored stones and rare mineralogical specimens for almost 2 centuries. Mines among forests and arable land. A long strip stretches the deposits of gems in the Middle Urals. To the north of Mazinka, they are lost in the lowlands and forests of the tributaries of the Tagil and Neva. In the south, some mines reach up to the area of the Aduya River. The continuous forest cover does not allow us to look for these stones even further south. But a little to the east, a new strip of gems replaces the Merzin granite. I remember my trips of 1912 to 1919. Leaving Yekaterinburg along the impassable mud of the Alapivsk highway, we found ourselves in the area of the forests of Monetnaya Docha. Here, in the wilderness of the forest, far from the main roads, in a low swampy place near the shores of the Adai, there are several buildings around a 20-meter shaft, leaving a void between them, usually filled with soft clay, in which large gem crystals up to 15 centimeters in length lie freely. In summer, the mine is flooded almost to the top. Work can begin only with the onset of frost, and the owner of this mine lives alone in a small hut, waiting for winter and workers. And all around there were continuous forests, here and there individual rocks, fragments of granite blocks, a number of pits, individual workings scattered in the forest thicket. The eye of the mineralogist almost did not look into these places, and for a long time in the mineralogical literature there was no mention of these deposits and their minerals. Meanwhile, there was a time when work was in full swing here, on the banks of the Aduya River. A group of miners united in the Kompanstvo managed to stumble upon a vein with beautiful gems. In 1899 to 1900, the Adui mines have long been famous for their amethysts, collected in beautiful parallel brushes, reaching very large sizes, weighing several tens of kilograms. Whole carts were taken away from here expensive stones and wondrous stuffs for mineralogical collections. But then hard times came for the Kompanstvo. The money earned was soon soaked up. The old Urals knew how to celebrate their finds of good stones, or gold nuggets. After a sensational period in the early 1900s, stone mining here almost stopped. Despite all the efforts of the owner of the main Semeninskaya mine, things did not go well, and the stone did not work. The vein did not give any more stones, and the water interfered with the work. In hard granite, without any technical devices, the work was not possible, and gradually pits began to collapse and wooden buildings began to rot. In general, the work of quarrying stones is difficult. It was difficult to set up a certain commercially profitable business here, and the success of mining operations on pegmatite veins of granites depended only on chance or luck. The area of pegmatite veins of Aduya covers a significant area of the former Monetnaya Docha, constituting the southern continuation of the Mersin Strip, and lies entirely in the Yekaterinburg district, now the Sverdlovsk region. Only 10 to 12 kilometers in a straight line separate this area from the southern tourmaline mines of Shaitanka. To the north, near Shaitanka, the same picture is repeated. Only the forests look more friendly and the arable land spreads wider, year after year, winning more and more space from the forests. Old pits have collapsed and are overgrown with thick thickets. Among them the pit of the Austrian mineralogist Moore, the commander of the lapidary factory, which at the beginning of the last century 1810 to 1812 supplied all museums in the West with rare tourmaline stuffs. The village of Shaitanka itself lies on the border of the Aduskoye-Hevsky forests. Through this village, bypassed by the large Neviansky tract, flows Shaitanka, a small river flowing into the Rez. In the village itself on the river, women and children washed ruby and sapphire pebbles in their spare time, and the gem mines were scattered around, mainly in the forests in the south and east. It is interesting to note that tourmalines were especially often found in nests, or, locally, bushes, and were contained in brown clay that filled pegmatite cavities. Large crystals of red, black, green and brown tourmaline were found here. Of particular interest are the red-brown crystals, the upper ends of which are colored wine yellow, while the lower ends are red-brown or brown. Occasionally, a layer of pink is added to these layers at the lower end. The same heterogeneity of color is typical for red crystals, in which the outer parts are colored with a thick tone, while the middle of the crystal is either colorless or colored slightly pink. In terms of transparency, crystals vary greatly from completely transparent to translucent. This colorful variety and often completely unexpected combinations of colors have won tourmaline the special love of the Ural miners. It is remarkable that they gave the name gem to this stone, and for a long time knew it only under this name, as if distinguishing this especially rich stone, saturated with all the colors of the rainbow, from the vast family of the patterned stone. The Shaitan mines are also of great interest from a scientific point of view. During one of my first trips, I still saw how diggers and tricksters were digging on the heaps overgrown with large birches, washing only individual crystals of this mineral. In Shaitank, there are still old miners diggers, with their love for precious and colored stone and with their faith in the riches of the bowels of their land. In the vicinity, you can find a number of new pits and ditches, scattered either in the dense forest or in the meadows along the ravines, laid either in solid granite or in serpentines. It is the miner who tries, often senselessly and without a definite goal, investing and burying both his money and his faith in his work. Of a completely different character are the famous mines of Lipovka, lying on a green meadow among the fields and representing randomly piled piles of dumps, many times revised and washed, among which gape half-collapsed mines, flooded with water. When you drive along the big highway from Novyansk to the village of Lipovskoy, then from the hill you see a picture of the village with a large church in the middle. It is located in the middle of an almost treeless landscape, and only on the horizon you can see separate strips of dark forests. Here, before reaching 2 kilometers to the village, just 200 to 300 meters from the tract, on the left slope of the Spaninsky Spoon, falling to the source of the Bobrovka River below the Lipovaya River, you see heavily swollen irregularities and pits of some old works. It is not easy to notice them, and I myself, who had been to these mines many times, sometimes happen to miss that small turn that leads to the right of the tract, to the Lipovsky mines located in the lowland. The mines were discovered quite accidentally in 1900, when red schorl crystals were ploughed out on the arable land with a plough. In the fever of the first 2 years, stones were mined by kilograms. Due to the disorderly and chaotic conduct of business, Lithuanian peasants not only ruined a huge amount of material of scientific interest, but also spoiled and distorted the deposit itself. The most valuable material of multicolored stones fell into the hands of the Lipovka peasants, and already in 1912 it was difficult to buy anything good in Lipovka, and the little that remained, for example, rubellite crystals, was valued at hundreds of rubles. In 1921, the situation in Lipovka changed dramatically, and local government enterprises began to properly organize the extraction of numerous and diverse minerals. In 1920 to 1923, due to the general weakening of the economic life of the Urals, these works were stopped. When you look with admiration at the pieces of precious minerals from the Lipovsky mines, in the Museum of the Leningrad Mining Institute or in the Museum of the University of Berlin, it is difficult to imagine the peaceful landscape that surrounds these classic mines, where the cover of black earth soil hides traces of grandiose physical and chemical processes. Only 30 kilometers separate us from Mertsinskaya Sloboda. The road goes through arable land and copses. On the sides of the road, the slopes of the valleys and spoons are pitted with pits and pits. To the left is the village of Serapolka, an ancient settlement, marked on the land map of 1734 and which made itself world famous for its tourmalines. At the end of the Zviy century, huge riches of bright red transparent tourmalines, sybarites, or, as they used to be called, Siberian rubies, were exported from here. In terms of density, uniformity and softness of the tone of the stones, no deposit in the world can be compared with Serapol. The Serapol radio-radiant intergrowths of pink color and great beauty are also famous. The ends of the crystals form a kind of spherical surface. Such intergrowths are very rare, and in former years they were valued extremely highly, and compartments of balls up to 10 centimeters cost at least 5,000 rubles in 1825. To the right, in the forest, the smoke of the Kurans near the Vitika mine slowly rises to the sky. There, at a depth of 75 meters, in a constant struggle with the accumulating groundwater, veins of amethyst of rare beauty, color and transparency are developed in the destroyed and altered granite. The extraction of this stone has continued successfully in recent times. Here is the Mertsinskaya Sloboda with its old church on the banks of the slowly flowing Neva River, disfigured by heaps of sands washed into gold. From the high slope of the river, a dense spruce forest is visible on the other bank, hiding the main deposits of the entire region, the famous Mokrusha and the Mountain Talion. In a damp, swampy and flat place among a dense forest, a number of mines are scattered in an area of only 1 hectare. Some of the mines have completely collapsed. Others have been working in winter and are somehow covered with boards. Scattered heaps were scattered around. In the midst of all this chaos of chaotic winter work in the frozen ground, only one mind made a sensible impression. This is an open development of CKH. Ural, with a depth of up to 12 meters. A small and low hut where diggers huddle in bad weather. A primitively arranged hand pump for pumping out water. That's all the unpretentious atmosphere of this working. Here only the picture of the deposit is revealed to us. Veins of pegmatite granite burst into the badly destroyed, folded nice like rock, now intertwining with each other, now branching thin white veins, then forming large clusters of hard but beautiful pegmatite rock. In the middle of the thicker veins, the rock left empty gaps during its solidification, and precious minerals of rare beauty crystallized in them. An experienced miner knows the guides to such rich voids, or burrows, as they are called in Mazinka, along a thin vein of granite going into the depths. He directs his work to a more powerful vein of the layer, where, by a number of minute signs or supplies, he predicts the existence of a void with semi-precious stones. With a special feeling of curiosity, we approached the newly discovered splinter. Brownish red, wet clay filled it, and SKH. Ural carefully and slowly took out this clay with a pickaxe and wooden sticks, fingering it in his fingers. Soon in his hands were excellent crystals of almost black smoky quartz and twins of feldspar. The workers and all of us were seized by a peculiar feeling of excitement. The eyes of all were fixed on Ujal's skillful hands, and everyone was impatiently waiting to see if this splinter had brought some gem. Soon Ural informs us that he is feeling with his hand on the walls of the cavity. Large crystals of smoky quartz and some mineral, possibly a heavy weight. The void is carefully washed away. Two explosions of dynamite cartridges in neighboring places completely clean it, and in our hands there is a number of smoky quartz pieces with green mica and crystals of feldspar and topazes. The topaz crystals of the Mazinsky mines are striking in their purity and tone. Their color is usually bluish, occasionally with a greenish or yellowish tint. Often the stones are completely colorless or colored in a faint pinkish yellow color. Usually they are completely transparent. The beauty, purity and tenderness of the tones of Merzin topaz are indescribable. One must visit the richest collection of the Mining Institute in Leningrad, or the Mineralogical Museum of the Academy of Sciences in Moscow to appreciate these gifts of nature with which no stone in the world can be compared. However, it is not often that hard work in hard rock, which yields only to dynamite, leads to such a snag. There are failures. Hundreds of rubles are buried. The development deepens. The pumping of water becomes more and more difficult, and the vein is always empty. But a good year also falls, and it brings happiness to the miners. Piles of expensive samples for collections and museums and hundreds of clean, transparent and brightly colored crystals. Such was the happy winter of 1910-11, when on the same Mokrish, in the Kolkin and Orlov pit, a gigantic void was found with feldspar crystals 3/4 meters long, with a huge bluish topaz weighing almost 30 kilograms. Delivered at one time to the city of Yekaterinburg, now the city of Sverdlovsk, disappeared during the Civil War. Only an exact model of it, carved from Sigazero talcum shale according to my measurements, flaunting on one of the pedestals of the Mineralogical Museum of the Academy of Sciences in Moscow, tells about the grandiose size of this heavyweight. All the accumulated stone was usually transported to the villages of Mazinka, Yujakovo or Maslyanka, where it was very soon sold to mineral buyers and collectors from Yekaterinburg. Every spring there was a large trade in stones collected during the winter. However, some stuffs were not commercially available. Often they passed from hand to hand. Their history is known to everyone in the Mazinka area, and after each transition to new hands, The price for them gradually increased. Work was no easier in deep amethyst mines, at a depth of 50 and even up to 75 meters. In contrast to the disorderly pegmatites with their sinuous and irregular excretions, amethyst veins had a regular, geometric character, extending as a solid wall to great depths. A large-scale development of amethysts in the stone moat near Vitika yielded for tens of thousands of rubles remarkable amethysts, burning with red fire in electric light, sparkling with red-blue reflections during the day. These stones were highly valued in Paris and London. Individual necklaces made of Vitika or Talian stones have been selected over the years, and more than once Sergei Chrysanthik Ujikov took a dirty rag out of his pocket and, laying out an almost finished necklace of 19 sparkling wonderful stones from it on the table, said to me, "I'll get 3 more stones here in the left half of the shear, and I'll take it to Paris myself." But these wonderful, sparkling stones could tell nothing about how this amethyst was mined in the stone moat. Here is what A.K. Denisov-Uralsky writes about their extraction. The light penetrates very poorly to the bottom of the slit, and the prospectors have to work with artificial lighting, usually with a simple candle. In such workings, workers descend into the mine in an ear on a worn-out rope, threatening death every minute to anyone who trusts him. But this does not stop the daredevils who are thirsty for profit. A burning sense of uncertainty, like the excitement experienced by gamblers or hunters who see their faithful dog making a stand, captures the prospector who has come across a vein that, according to his signs, promises a nest of amethysts. The excitement is breathtaking. With feverishly shaking hands, he chips off pieces of rock, expecting to see an expensive crystal every minute. It's worth the risk. There is a lot of peculiar poetry here. There are prospectors who have a special flair and the ability to track down a vein and predict what it can give. Such people with ingenuity and experience are very highly valued in the field of intelligence and enjoy special honor. In difficult cases, when the trace of the vein is lost, the owners of amethyst deposits resort to the help of experienced prospectors who go down to the mines for exploration for a good treat, attentively, step by step, inspecting the vein from the very surface of the mine, swinging at a dizzying height in a tub on a rope that threatens to burst every minute. Such a connoisseur will certainly find the real trace of the vein, a leader or a sweep, and direct the work to the right path. In 1911–1912, the struggle for the gems of the Urals intensified. In the local newspaper of Old Yekaterinburg, Voice of the Urals, there were articles highlighting the difficult situation of production, reproaching the government and landowners of the Urals. A meeting of handicraftsmen was held, and then a special meeting was held in the mining department in Bureaucratic Street, Petersburg. As a result, a bill on benefits was prepared for mining gems, but this project was almost unanimously rejected by the miners, as allegedly threatening the further development of the entire mining industry of the Urals. And the end of 1912 was at the same time the end of new aspiration for the extraction of gems. Handicrafts remained as before in the hands of a few artels and entrepreneurs in some places. It was engaged in by district zemstvos and cooperative organizations, on a par with the procurement of butter and eggs. But the business was killed at the root and, most importantly, the incentive to work was destroyed. Such was the unsightly picture of the extraction of gemstones in the Urals, and especially in the Mazinka region. On the settled places of Mokrusha and Vitika, old men of the old school, armed with long experience and driven by love for the gem, lived out their days. I have seen such miners who carefully kept their favorite stuffs or crystals in their chests, and only agreed to sell them only a few years after the discovery. They were not just trading the stone, they were proud of their prey, proud that they had managed to snatch it from the raw horses, but their love for stone was almost not passed on to the younger generation. Significant risks in mining, hard physical labor in the mines in winter, the absence of any organization in the conduct of work, and difficulties with the sale of material. All this pushed the younger generation away from the favorite occupation of their fathers and grandfathers. The craft of colored stones and gems was slowly dying out. The old places were worked out, new ones were not opened, and it is difficult to discover them when everything is hidden under the cover of forests and arable land, when there was no mountain freedom of search, the right to mine and to lay pits in state and possessory possessions. Only occasionally the elements helped the miners. A storm would sweep over, uproot the tree and knock it down, and in the giant rhizomes, as in a vertical wall 5 meters high, traces of new pegmatite veins, new gems were revealed. But such accidents are rarer part of the peasants, endowed with meager plots of land from the factories. More and more went into arable farming, the other, bypassed by the allotment, goes to seek happiness in a foreign land. Old Mazinka was receding into the past. The first pages of its 200-year history were coming to an end, and in order for the next page to open, it was necessary that the old forms of industry should die, that the revolution should overthrow the power of the miners and concessionaires. It was necessary that the first difficult years of the restoration of the economy, devastated by the war, should have passed, and only then a new page in the history of the Ural stone was opened. The old miners of Mazinka and the old lapidary factory in Yekaterinburg were replaced by a qualified miner and a lapidary of the new enterprises of the socialist system. Mazinka has become the property of all the people, and it is not a rich jeweler or a buyer of gems who is drawn to her, but lovers of stone, starting with mineralogistic scientists and ending with pioneers who make trips to Mokroshka and Alabashka in search of gems. Birth of gems. Russian scientists paid little attention to Mazinka, this pride not only of the Urals, but of the whole world. To the shame of the 19th century, these mines, unique in their richness and beauty, of gems and the rarest minerals, were not only not described, but even little visited by Russian mineralogists of the old schools. Meanwhile, these deposits deserve a detailed scientific study. They open before us the pages of the geological past of the Urals, and unfold grandiose pictures of geochemical processes. The time of the formation of these deposits of gems belongs to those distant geological epochs, when the Urals gathered in mighty folds and slowly, from east to west, the strata crept over the strata, restrained by the unshakable and calm platform of the central Russian plain. The whole suite of ancient deposits, from the deposits of the epochs hidden from us in the darkness of the geological past, to the Silurian and Devonian, broke helplessly under the pressure of forces from the east, rose in steep folds and overturned on their heads. Powerful streams of igneous rocks found an outlet among these crumpled layers. They froze, flowing in a continuous stream between the layers, then rose to the surface in the form of veins and spilled out like lava. In some places, molten masses impregnated the ancient sediments and thus recrystallized and changed them. In some places they dissolved fragments or entire layers of rocks captured along the way and, renewed in their composition, then solidified in the form of completely new, peculiar rocks. At the same time, some chemical processes were replaced by others. For long geological epochs, probably long before the Carboniferous period, the site of the modern Urals was restless. In a talented overview of the face of the earth, the geologist of the last century, Edward Swiss, beautifully depicts the grandeur of these paintings and the uplift of the Urals at the end of the Carboniferous epoch appears to him only as the sharpest and last paroxysm of a powerful and protracted geological process. Among all the igneous rocks of the Urals, granites attract our special attention. They form the basis of the entire eastern slope, and the main riches of metals and semi-precious stones of the Urals are associated with them. Some of them rose in the form of domes or froze in the depths, even before the Ural range finally froze. This older generation of granites, together with all its veins and inclusions, experienced the fate of other rocks of the Urals, and little, by slow recrystallization and melting into sedimentary rocks, turned into granitogneisses with a clearly expressed, layered structure. But in addition to these granitogneisses, we see in the Middle Urals grey thick masses of granites of a different age. It was they who brought with them from the depths significant masses of various rarer chemical elements, and the origin of gems in the area of Mazinka and Aduja is connected with their history. During the constant but slow processes of mountain building, molten granitic magmas solidified, slowly releasing mineral after mineral in strict sequence. Just as milk, settling, collects on its surface more and more fatty components, so granitic magma has divided, as petrographers say, differentiated, into chemically heterogeneous layers. The more basic minerals, rich in magnesium and iron, crystallized earlier and sank down. What remained was a more acidic, that is, more silicic acid quartz-rich molten mass. Vapors of volatile compounds accumulated in it. Negligible amounts of rare elements dispersed throughout the magma were drawn to it, and significant masses of superheated steam were impregnated with it. From the surface, the granite mass was already beginning to harden, but the resulting thin film was torn and covered with cracks. The vapors accumulated under it broke through it every now and then and opened access from below to other masses of molten rock. In these cracks of surface cooling, remnants of magma rich in silicic acid, collected water vapor and volatile compounds penetrated here, and slowly, according to the laws of physical chemistry, these masses solidified and crystallized, forming the so-called pegmatite veins. These veins, like branches of a tree, diverged away from the granite half, cut through the surface parts of the granite massif in different directions, and broke into the binding shell of other rocks. We now know with some certainty that the crystallization of such veins took place at a temperature of 700 to 400 C. There was no melt in the full sense of the word, and there was no pure aqueous solution, but it was a special state of their mutual dissolution and saturation with enormous quantities of vapors and gases. But the hardening of these veins was far from easy and not fast. It began along the walls of contact with foreign rocks and slowly spread to the middle, narrowing the free space of the vein more and more. In some cases, coarse-grained masses were obtained, in which individual crystals of quartz and feldspar reached a large size up to 1 meter, and plates of black or white mica reached the size of a large plate in others. Individual minerals were replaced in a strict sequence, but more often those amazing structures were obtained, which resemble a kind of writing and which are commonly called pegmatites. Such pegmatite structures, from the smallest, barely perceptible sizes to giant forms of excretion, where the size of feldspar and quartz crystals reaches 1/4 of a meter, are the main and most important rocks of pegmatite veins in the Merzin region. From them, the miner prospector guesses about the possibility of finding voids with colored stones. From them, the mineralogist judges the nature and conditions of the formation of the vein. But the formation of beautiful written granites does not end the filling of the vein. Very often, between both walls, there is still an empty gap in the form of a narrow slit or in the form of a whole void or burrow. In these voids, all those elements and compounds begin to crystallize, which in the form of volatile vapors saturated the molten mass or were dispersed in the magma. In the smallest quantities, beautiful crystals of smoky quartz and feldspar grow along the walls of voids, and cracks boric anhydride vapors accumulate in the needles of tourmaline, sometimes black as coal. Sometimes beautiful red and green tones, volatile fluorine compounds, form bluish, transparent topaz crystals, like water. In a variegated beautiful picture, these minerals are intertwined. They owe their formation to the four main and most important elements of these veins: fluorine, boron, beryllium and lithium. Each of these four chemical elements plays a different role in the history of the formation of colored stones. In some veins, boron predominates, and black tourmalines are formed in them. In others, other elements accumulate, and beautiful gem crystals not only line the cavities of the cracks, but also completely penetrate the entire pegmatite rock. These four elements are joined by a whole galaxy of other metals, which are part of rarer minerals, sometimes forming the smallest crystals that are still poorly studied, all of which come into the vein from the depths, from the inner chambers of the granite itself. But the nature of the minerals of the pegmatite vein depends not only on them rising and making its way. Molten granite magma captures fragments of rocks encountered along the way, dissolves them in itself, which inevitably leads to new mineral combinations. If limestone is found, then tourmalines acquire a red color associated with a high calcium content. If serpentines or other magnesian rocks are cut through, a special kind of feldspars are obtained, and tourmalines become brown. A number of regularities connect the shape and color of vein minerals with the physico-chemical processes that initiated them. This is how semi-precious and colored stones were formed in the pegmatite veins of the Merzin region. But little by little, the deep chambers of magma froze. Hot aqueous solutions in the veins cooled down, and the release of vapors of various compounds stopped. The movement of the Earth's crust in the Urals stopped, and powerful surface workers began their destructive action, demolishing mountain ranges, destroying and washing away strata and veins. Mountainous countries turned into plains, and granite massifs turned into gold-bearing sands. Organic life, with all its chemical agents, has subjugated the upper horizons of the plain and turned them into fertile soil. From rivers, streams and swamps, water penetrates deeply into the earth, and with it, atmospheric destructive figures, carbonic acid, oxygen and organic acids. Through the smallest cracks and capillaries, water penetrates into granites, turns feldspars into clay masses, extracts and oxidizes iron. These waters flowed through the voids of pegmatite and ore veins, filled them with brown clay, a product of the destruction of the surrounding rocks, etched out crystals of quartz and other minerals, or covered the walls of cracks with a thin film of secondary minerals. The continuous forest and soil covered with an almost impenetrable veil, the traces of former grandiose chemical processes, and it is difficult to read the past of the Ural range in this plain with individual fragments of granite rocks. In the Iletsk Defense, 70 kilometers to the south of Orenburg, among the bare feather grass steppes, rises the lonely gypsum rock of the Iletsk Defense, which has its own long history. At the foot of the rock, as early as 1741, the extraction of rock salt began, which protruded in snow-white rocks from under the soil cover here. Beyond the course of the Ural River, numerous carts converged here. During the Pugachev period, there was a prison on the top, which, however, did not save the city from being conquered by Pugachev's comrade-in-arms, Klopusha. Since then, the Iletsk city began to decline due to the complete lack of roads. Salt production sharply decreased and the fishery was threatened with a complete cessation. In 1817, quite large and regular work was started and the collapse was laid, which in the next 70 years reached significant dimensions and great depth. However, the abundant influx of water greatly interfered with proper operation. Hot winds in summer carried dust and clogged the mined salt, and in winter, during snowstorms, they had to completely abandon work. Back in 1889, it was decided to start underground work. and the collapse began to slowly fill with water until in 1906 water poured into it from the Peshunka River and turned all the breaking into a huge salt lake, more than 300 meters wide and up to 20 meters deep. In 1914, when I happened to be there, the buildings of the salt mine were located on a small hill, southwest of the city and Gypsum Mountain. They adjoined the salt lake. From the west to the north of them is a small fresh dam, formed by the Peshunka River. To the south, to a distant space, stretches partly bare, partly feather grass steppe, burnt and cheerless, with herds of horses and some gloomy figures of camels. In the village of the salt mine, you cannot see the hustle and bustle and mud so common for mines and mines. Not a single piece of fossil extracted from the depths catches the eye. You enter a small house above the mine, put on a work jacket and, using a pocket electric torch, under the guidance of a steiger, begin to descend a comfortable wooden staircase, here and there lit by electric bulbs. Very soon, the wooden walls are replaced by a grey crystalline mass of solid rock salt. At a depth of 40 meters, you find yourself in separate wide galleries of old developments around. It is pure light grey salt, sparkling in electric light. It is so hard and dense that it does not need any wooden supports. On the floor and on the ceiling vault, under the influence of flowing water, it crystallized into fluffy snow-white masses. Long stalactites of salt descend from the ceiling like ice icicles, and from below the same stalagmites grow to meet them. However, it is not in these tunnels that rock salt mining is carried out. You approach a large inner window, and a majestic picture opens before your eyes. Under your feet below, there is a huge hall 70 meters deep, 25 meters wide and 240 meters long, and the length is almost 1/4 of a kilometer. At first, we are under the very roof of this working, almost unique in the world in its grandeur. The wooden ceiling covers the entire surface of the hall. Since a fall from such a great height of even an insignificant salt stalactite would threaten death to those working in the depths, not a single layer of gypsum or other minerals breaks the monotony of this picture. Only every meter there are horizontal parallel lines, notches of 10 to 15 centimeters. The entire hall is lit by 8 electric lamps of 700 candles each. It takes a long time for the eye to get used to such a bright light, and only after a while you begin to distinguish the trolleys below. People, a whole teeming anthill. For a long time the descent into the depths along the stairs, covered with sparkling salt crystals, continues, and finally, we are downstairs, on the floor of the same salt. Mining is methodical, in a strict order. Deep trenches for meters deep for ledges of 1 meter each are cut off from the walls, with axes on long handles, and then all this mass of salt begins to be removed from the middle to both sides of the hall. On the right side of the hall, drilling and laying of powder cartridges is underway. On the left, the excavation of the exploded mass, stacking in trolleys and delivery to the central mine. Every other day, the work is transferred to the other side. Slowly remove ledge after ledge until the salt is completely worked out on all 4 ledges, and again begins in the middle of the trench laying, etc. More than 250,000 kilograms of salt rise to the surface every day, and about 500 people are engaged in this work. The viscous, soft, raw mass of salt does not break easily, and sometimes it is necessary to strike many times with a bowker before it is possible to break the blocks torn off by the explosion. However, this stubbornness of the material is redeemed by a number of other favorable working conditions. Here, in the depths of the gigantic hall, an even temperature of 8 to 9 C always prevails. Neither snowstorms in winter nor the hot, scorching summer sun penetrate into these depths, and under the armor of 20 meters of clay and sand and 30 meters of salt cover, the work proceeds completely calmly. The broken salt is sent to a shaft, through which individual trolleys are constantly rising to the surface of the earth. Here the salt enters extensive barns, is somewhat dried and goes into grinding. Salt is poured into bags and loaded directly into wagons, supplied along the railway line laid here. The salt is so pure and homogeneous that it does not need any selection and can be directly used. Its purity is evidenced by the following data, established by the analysis made in the laboratory of the Mining Institute. Sodium chloride, 99,190% magnesium chloride, 36% calcium chloride, 82% calcium sulfate, 435% insoluble residue, 85% humidity, 170% in the following years. The Eletsk Defense expanded its activities more and more. One hall is no longer enough, and a project for the arrangement of a number of other halls, similar to the one described, has already been developed. This is how a grandiose picture of salt development in the steppes of Orenburg is drawn before us. And only a certain threat is posed by a deep lake stretching to the east of the mine, a blockage. Every year its banks are eroded, and it is getting closer and closer to the underground working. This lake involuntarily attracts attention with its unusualness. This is not only a landmark of the entire region, but also a deep mystery for modern science. Filling the old development, it is now gradually turning into a medical resort. Thousands of patients gather under the hot sun on its banks, and its water is so saturated with salt that it does not allow bathers to go to the bottom. Beautiful snow-white rocks of bizarre shapes on the western side consist of crystalline salt. The heavy waves of the salt lake polish them, in some places forming deep caves and depressions. On the surface, water burns when it comes into contact with it. Thus, according to the measurements of the geologist L.A. Yuchevsky on July 27th, the water temperature during the day reached 36.1 C. However, as you deepen, the temperature drops sharply. L.A. Yuchevsky gives the following interesting table of water temperatures in the lake at different depths. Depth in meters / temperature. 0, 1/30th C1, 1/25th C5 over 1 C2 C10 fifths, C15 quarters, C5.5 C19, 5 C. Thus, the cold reigns in the depths much below zero even in the hottest summer time. This amazing drop in temperature, noticed by the famous Russian geologist S.N. Nikitin, has not yet found a complete solution. According to L.A. Yuchevsky, who studied the thermal properties of the lake, such a decrease in temperature in the depths, at a very high temperature of the atmosphere, must be associated with special physico-chemical processes occurring with the absorption of heat in a saturated brine medium. From year to year, the lower horizons of the lake must be subjected to more and more cooling, and the whole lake, according to L.A. Yuchevsky, can be considered as a natural accumulator of cold. This phenomenon has been the only one to date. We know of a number of lakes, especially in Hungary, with just the opposite properties. In their lower horizons, under the cover of a layer of fresh water, summer heat collects. A detailed study of the thermal regime of Lake Eletsk has already been planned, and it is all the more interesting and important because the lake has a significant future ahead of it as a result. Another small phenomenon noted by L.A. Yuchevsky deserves mention. To the northeast of the lake rises the Gypsum Mountain with the remains of the old Cossack prison. A number of houses of local residents cling to its steep southern slope, who use part of these gypsum rocks as glaciers. In some places, it is enough to lean a building against a stone wall and thereby isolate this part of the rock, in order to get a natural glacier with very low temperatures. Since gypsum carries strong cold from cracks and voids, I personally felt this cold stream of air in a number of glaciers, and this phenomenon cannot but amaze with its originality, especially in the days of summer heat. Obviously, This phenomenon is somehow connected with the salt lake or with salt deposits in general, since there is no such cold on the northern and western sides of the same mountain. On Mount Kumb, completely different impressions and different pictures were revealed to us. In the taiga of the northern Urals, in that rich Bogoslavsky mining district, where more than a century and a half ago mining was first born in the Urals, legend says that the rich ores along the Turai River were discovered by a Vogel, who in 1754 wandered into the taiga of Bogoslavsk on the tracks of a deer chased by bears. The enterprising Vokotchary merchant Pokodyoshin learned about this find, and in 1757 he built the Petropavlovsk plant on the Kalonga River, here on the steep eastern slope, in the taiga, which has still retained all its characteristic features. One of the richest mountain districts of the Urals arose from a small hill near the Bogoslavsky factory itself. The chain of the Ural Mountains opens up in all its grandeur at your feet. There is a factory pond. In the distance in the west, 40 to 50 kilometers, the inaccessible peaks of the main ridge stretch in an uninterrupted chain, with white spots of snowfields, with alpine meadows and rocky peaks. And at the foot of the mountains, there is an impassable swampy taiga. These pictures are little known to those inhabitants of the Urals who are accustomed to the soft and cheerful views of the middle and southern parts of these mountain ranges. In the south, you can see the Konjakovsky and Talaysky stones, and far in the north, you can see the beautiful contours of the Deniskin stone about 2,000 meters high, and against the background of them the pointed peak of Kumba about 1,000 meters high. Is the goal of our trip. In 1914, we were led to this mountain by old literary indications that among the minerals of Mount Kumba, there are some rare and valuable compounds. No matter how problematic this indication of a very old researcher dating back to 1840 seemed to us, nevertheless, in connection with the general study of the minerals of the Urals, it was of certain interest and had to be checked and confirmed. Although our inspection yielded negative results, nevertheless, the inspection of Kumba and the northern part of the Bogoslavsky district significantly supplemented our material with new observations and impressions, completely unusual for a mineralogist accustomed to conducting research in the rugged regions of the Middle Urals or among the picturesque and friendly southern steppes. The broad-gauge railway took us only to the Nadezhdinsky plant. From there, along a narrow-gauge track in a small car of a local train, we slowly began to move north along the Vagran River. From here the path lay on horseback through the picturesquely sprawling, but now abandoned Peter and Paul plant, and then up the valley of the Kalonga River, to the very foot of Kumba, where a cordon had just been built in the forest on the bank of the river. The excellent highway, sprinkled with dross, soon gave way to a forest road, and then only a distant semblance of a road we had to walk, and the horses had difficulty dragging our luggage over stumps, roots and stones. The next morning we began the ascent, which we expected would not be particularly difficult. However, soon we entered an impassable area of hummocky swamps covered with dense forest. The swamps were replaced by a gentle slope covered with typical taiga with overturned windbreaks. Also on trees they had to climb over the moss-covered trunks of 300-year-old giants, pines and cedars. Thick black nets on our heads and gloves on our hands did not protect us from a swarm of mosquitoes, and the net, unusual for us, made it very difficult to breathe. Higher up, the ascent became even steeper, and in the evening we found ourselves in the area of heaped rocks. The destruction of solid rock, olivine gabbro, here takes on grandiose proportions. Fragments of boulders eroded by water and air roll down from the top in all directions. Almost the entire mass of the mountain consists of gabbro, once frozen in the depths in the form of a powerful massif. In vain we searched for minerals in its monotonous crystalline mass. Only here and there in the once molten grey rock, masses of magnetic iron. have accumulated traces of copper. Plaques of epidote broke the boring monotony. The wind has risen. A damp, cold fog enveloped the peaks of the mountains. Under an overhanging rock, near a small reservoir, we made a fire and began to prepare for the night. Sometimes the wind dispersed the clouds. A ray of sunlight broke through, illuminating the boundless picture of the Siberian taiga far to the east. After a little rest and warmth, we decided to climb to the top. But the highest point of Mount Khibiny turned out to be inaccessible, and only occasionally appeared in the form of a pointed peak among the creeping clouds. The grandiose screes above were replaced by peculiar meadows of the alpine type, or a thick soft cover of moss. We walked around the northeastern slope, collecting material and examining the monotonous gabbro rocks, but our search was fruitless. It was already dark when we went down the rocky dumps and found a place to spend the night, after a cold night and vain attempts to warm ourselves by the fire. One of our companions undertook a second inspection of the summit, approaching it from the other side, but this inspection did not yield any results. The damp cold weather did not allow us to stay longer on the summit, and severe fatigue and an insufficient supply of provisions with us forced us to abandon further inspection of the southern slopes and begin the descent. After the rains of the last few days, this descent turned out to be very difficult in places, and in the swampy lowlands we moved even more slowly. The damp and inhospitable taiga was completely lifeless, and only here and there a deck torn by claws reminded us of the bear, the main inhabitant of these forests. Thus, our search on Mount Khibiny not only yielded negative results, but also showed the futility of further research. Nevertheless, we decided to inspect the nearest area adjacent to the mountain, and all the pits at the foot of the mountain. On the Kalonga River, not far from our cordon, our search brought us some success. In an old iron mine, Pokrovsky and Kolomsky, now being prepared for large works, we met with a number of formations that would seem to be interesting. Here, igneous rocks, close to those that formed the peaks of Khibiny, broke through into the limestone region. Huge accumulations of magnetic iron ore were released from the molten magma, and the limestone itself turned into garnets and epidotes. In some places, the long prisms of the epidote were enclosed in a mass of magnetic ironstone, which not only covered them with a black crust, but sometimes completely replaced the substance of the epidote. As a result, black prisms were formed, the appearance of which sometimes resembled the structure of some rare earth compounds, to the smallest detail. Perhaps it was in these prisms that the researcher of the 40s of the 6th century suspected the minerals that he wrote about in his work. It is difficult to give a definite answer to this question, and one can only regret the incompleteness and brevity of the old description. Only when one finds oneself in some foreign land, guided by old materials or old routes, does one deeply learn to appreciate those few researchers of the past, who were able to combine the breadth of scientific thought with the accuracy and detail of the description of their observations, to give an accurate description of the observed phenomena of nature, to snatch from the variety of details and trifles the main, characteristic features, to formulate in a sharp and concise form everything that the eye has seen and the thought has grasped. This is such a complex and important task that all the difficulties of laboratory research or theoretical analysis in the offices of scientists pale before it. And perhaps in our time, when, at the rapid pace of life, the thought of the natural scientist very often runs ahead, breaking away from facts and observations, it would be useful to look back at our great predecessors of the late 18th and early 19th centuries, who, in their calm epic narratives, slowly prepared the foundation for the construction of the majestic edifice of modern natural science, assembling for it, one by one, the bricks of accurate observation of nature. It was not ideas or great generalizations, not the conquests of abstract thought, that created our modern natural science, but it was the result of that dull and difficult, thankless descriptive work, thanks to which, in the course of more than 2 centuries, facts have been piled up upon facts. Separate links have been forged in that great chain of laws of nature, which have succeeded in uniting into a beautiful whole in our years. In the years of critical revaluation and creative work, rarely in the southern Urals, in the mines and construction sites of the southern Urals. In recent years, many significant events have taken place in the life of the South Urals, which have completely changed its entire economy, its entire former appearance. A new Chelyabinsk has grown up with its powerful energy-based shegers, which sends electricity not only to its giant plants, such as the Ferroly plant, the Aland and Tractor plants, but also further to Zlatist and Sverdlovsk. Magnitogorsk was built and is in operation, the pride of the Soviet Union. It was born from the cooled ashes of legendary stories about the former glory of gold mines, a new, largest mechanized gold industry, which gathered and united in Artel's prospectors and old seasoned gold prospectors, and ardent Komsomol members from Cossack villages and Bashkir villages. Gone is the old Urals with its rich factory owners, gold and pillar miners, English, French, Belgian and all sorts of other companies, with its Demidov and Rostov habits and traditions, with its unrestrained drunkenness, ignorance and lack of culture. The old Urals were replaced by the Soviet Urals with advanced technology in factories and new buildings, with combines in the fields, highways, cars, with bright schools, cinemas and theaters, with a young bustling life. New railway lines stretched like steel bands. Ores of chromium, manganese, tungsten, nickel, aluminum, previously unknown even in these parts of the Urals, began to be developed. The industry of the Urals is being renewed and growing. New centers of economy and culture are being created at an ever-accelerating pace. And so in 1932 I again made a trip to the Urals. We are flying by plane through the South Urals, around the shacks of old Kelyoba. A ring of new buildings of new, industrial Chelyabinsk is white. The chimneys of the Shegers power plant are smoking, cutting through forests, valleys and mountains. Hundreds of millions of kilowatts of electrical power transmission lines stretch in all directions. The pictures of narrow patchwork fields, interlaced stripes of the old Russian village, familiar to us from old trips, are replaced by a completely different pattern. Large canvases of collective and state farm fields cover the foothills of the Urals, with large homogeneous and monochrome spots. There is a whole network of railways around Chelyabinsk, and new double strips of rails stretch to the well-known feather grass steppes of the southern plains. The earth is hidden in the clouds for a while. The compass needle trembles. Several sharp turns pull the plane out of the fog, and suddenly a picture of Magnitogorsk spreads out under your feet, the most complex, even incomprehensible intertwining of houses, factories, plants, roads, railways, the still emerging giant of the Urals Kuzbas. The 34th year comes. In the blooming southern spring, we leave the Omensky Mineralogical Reserve in a car, our all-terrain vehicle of the Gorky plant, a passenger car, nicknamed the Mayas Children, to inspect the new industrial centers of the South Urals. After a few hours of travel, we find ourselves at the Khibiny plant, which once belonged to an English company, which now produces a significant part of the copper mined in the Soviet Union. 2 or 3 hours take us to Zlatist with its largest Soviet blooming another 7 hours, and we are at the gates of the Ural nickel plant, and at the deposit of beautiful grey wavy marble, which is now so familiar to all of us from the Moscow metro. 7 to 9 hours of travel separate us from Magnitogorsk, with its annual capacity of more than 3 million tons of pig iron upon completion, that is, an amount equal to almost the entire productivity of ferrous metal in Tsarist Russia, and from the same Omensky reserve named after V.I. Lenin, through blooming collective farm fields and a new clean state farm. In 3 hours we get to Chelyabinsk, the city of the future, which is still under construction, still growing. In front of us and around us grow the hulks of Tractony, and when you wander among the flowers and green lawns scattered between the individual workshops of this wonderful plant, it is difficult to imagine that tens of thousands of powerful tractors are born here every year. As a result of the complex work of machines, tools, conveyors, furnaces, more and more new factories follow. At this plant, as in the mouth of a volcano, at a temperature equal to the temperature of the surface of the sun, about 3,000 to 4,000, ferroalloys are smelted, the most complex chemical compounds necessary for high-quality steel, and the artificial precious stone ruby, weighing several tons, is extracted from the furnaces by powerful cranes in order to turn it into emery powder for abrasive production. Further on are the buildings of Shegers, the zinc plant, the site of the Bukolsky plant, the plant of white paints extracted from the black titanium ores of the Kaczynski deposits. Nyazlatist, the heavy industry of Chelyabinsk and its region made the most valuable supplier for the entire union of those metals, alloys, tractors, machines that were previously imported from abroad in huge quantities. A new world center of industry is growing on the site of the old merchant Kalioba, as a new powerful tool rebuilding the geographical map of our country. In the autumn of 1934, we were again in the Omensky Reserve named after V.I. Lenin, on the open balcony of an old wooden house. The first scientific conference of the Chelyabinsk region is taking place. The greatest specialists, experts in the South Urals and its riches, came here to sum up what had been done and discuss the problems of future work. On the balcony, the chairman, with a bottle in his hands instead of ringing the bell, is leading this extraordinary meeting among the wondrous pine forest, among the blooming nature of the southern Urals. Little is enough, say experts. We know our riches. It is not enough for us that more than half of all iron ores in the Urals have been identified in the region. It is not enough for us that many Ural reserves of copper, zinc, and aluminum have been discovered here and are ready for industry. That nowhere else do we know of such deposits of magnesite, talc, and chromite as here, in the southern Urals. That the still little known minerals of the future kyanite and vermiculite are of world importance. It is not enough because the wealth of the southern Urals is still boundless and boundless, because tens of thousands of square kilometers of its mountain ranges have never been studied by geologists and geochemists, because the still unknown riches are hidden under the cover of fields and steppes. Both geologists and geochemists painted in bright colors the remarkable geochemical laws of the distribution of metals, ores, and minerals on an area of almost 1/3 square kilometers, discussed and outlined new ways for prospecting, drilling and exploration. Later in the same autumn, in November, a conference on coal and its chemicalization was also held here. This conference, having held a number of meetings in the Omensky Reserve, went by car to the Chelyabinsk coal mines in order to find out the details of the issues facing the conference on the spot. As a result of the conference, 2 books were published: Problems of Geochemistry of Basic Magmas and Chelyabinsk Coals. Already in 1934 it became clear that it was necessary to organize a large-scale complex expedition the following year, which would take upon itself the study of a number of problems connected with the increasing rate of development of productive forces, with the construction of new largest enterprises, and would solve a number of problems arising from this: forestry, water resources, communications, etc. The Council for the Study of Productive Forces of the USSR Academy of Sciences undertook this important task. It was decided to use the State Omensky Mineralogical Reserve, located near the Maya station, at the foot of the famous Ilmen Mountains, and which is the geographical center of a large region of the southern Urals, as a base. To organize here a research station with laboratories for the study of urgent problems of the most interesting developing industry, which could determine its future paths and help plan new lines of socialist construction. The Lomonosov Institute of the Academy of Sciences has long been studying this amazing region, the significance of which was so brilliantly foreseen by V.I. Lenin back in 1920. And since then, from year to year, the Umensky Reserve has been growing. This base of scientific works has been strengthened. In the summer of 1935, the South Ural Complex Expedition began to work in the South Urals. It scattered its numerous and diverse detachments over the vast expanses of Bashkiria, the Chelyabinsk region, the Orenburg territory, and western Kazakhstan. The scope of her work included the study of minerals and their geochemistry, geological issues, which are extremely complex in this part of the Urals, forestry, in order to indicate new methods for its rational development, hydrology, taking into account water resources for existing and emerging new industries, soil science, as a concrete basis for collective and state farm construction, and, finally, the economy in order to outline the correct line of development of the national economy and the path of commodity turnover. Our brigade was supposed to make a motor rally in the Urals and carry out the following tasks: to get acquainted with the work of the detachments in the area of the South Ural Complex Expedition, with a number of historical deposits, with new construction sites, new problems. In addition, it was decided to use this trip to collect minerals for the Mineralogical Museum as the first experience of using a car for field museum work, which would provide an opportunity to visit many deposits in the shortest possible time and collect museum specimens of large size. The run time was limited by tight deadlines. The route is scheduled by day. Trips from Myas to Chelyabinsk and Sverdlovsk taught us to be prepared for any eventualities on the way, to have spare parts, cylinders, tires, tools, etc., a supply of fuel, wheel changes, tires, tents, sleeping bags, food, wrapping paper, tools, etc., were placed on the truck. Myas, Kokka, Kartali. Departure for Kokka, the ancient center of the gold industry, was scheduled for 6 a.m. on August 2nd. The first part of the way from the reserve through the Myas railway station, and then the city of Myas, is the most unpleasant. A bad road, a lot of dust. After passing the city, the cars drive onto a wide road to the village of Chernaya Reka and head further to the picturesque lakes of the large village of Kundravy. From here we took a steep east along the Chelyabinsk highway, and here we had our first and only accident. The truck lagged behind, and when it finally arrived, its front spring was broken. We barely reached the Medvedevsky State Farm. It is a whole socialist town with a power plant, with a splendid fleet of agricultural machinery, with boundless masses of fields, with workshops, schools, and everything that is so characteristic of our new construction. In a large workshop, the spring was rebuilt by the driver of the car, A.V. Babkin, who was always cheerful, energetic, and ready to help everywhere and everyone. Apart from this repair, our cars were not repaired anywhere during the entire journey. From here the cars turned south to the big Kokka highway, and along a beautiful steppe road they carried us to the former capital of goldsmithing, Kokka, where 50 to 60 years ago mad gold was mined, where blind fortune turned some into rich and ruined others, where legends about fabulous riches were associated with each gold mine. But that was a long time ago. Gold was mined. Some drank it on the spot, others lost at cards. The edge died out, and it seemed that there was no longer a place for a gold prospector and an engineer. But a new time has come for this region as well. A new owner has come, with new technology, with a new ideology, and the gold business has come to life. giving metal in an amount exceeding the old mines, covering the set norms. Unrecognizable edges, telephone lines and power wires stretched everywhere. The dwellings of many prospectors, gold miners, are radioed electric light everywhere. Bicycles and light high-speed vehicles became firmly established in everyday life. We passed Koka. Our nearest stop is the so-called Plast. Large plant installations for the extraction of gold from primary deposits are concentrated here. There are deep mines, a cyanide factory and the management of the gold-bearing region. Meeting with managers, engineers and technicians. We are visiting the new district museum. We are shown a new find from the Andreevsky mine, scheelite in limestone. 2 hours pass unnoticed. We are in a hurry to leave in order to stop for the night, somewhere closer to the Borisov Hills. Before dawn, an hour later we stop at the village of Klyach, near a large prospecting work. We are in the center of the old and new gold industry. In the area where in the old years 1850 to 1870, the first finds of pink topaz, then corundum, euclase, chrysoberyl and kyanite were made during gold panning along the Kamenka and Sanarka rivers. It is interesting to note that, as can be seen from the documents of the archive of the mining department, already in the 30s of the 6th century, there were some indications of colored stones in the Troitsky district along the Uyu and Uvalka rivers. In the archive there is an agreement with the landowner Bolkashin on the extraction of rare metals and precious and non-ferrous stones in this area. The area of the Sanarka River and the Kamenka flowing into it, tributaries of the Uwai River flowing into the Tobol, is the southern continuation of the Koka places and is located 20 kilometers south of Koka, among flat feather grass steppes with rare birch groves. Among the low, reed-covered banks flow shallow rivers, Sanarka and Kamenka, with which the mineralogist has so much to do. A rather monotonous picture of the steppe character with dug-up and randomly piled sands is enlivened by a hill bordering the area of places, and called the Borisov or Sokolin Hills. These hills with their individual ridges, tips, are composed of mica cyanite quartzites. Most of this area is occupied by granite, on which islands of carboniferous marble-like limestone still survive in some places. The main places are located in these limestones, partially cut, like granites, by quartz and feldspar veins. Some of these veins are strongly kaolinized and form clay accumulations in the limestones of some mines. It is with these veins that we have to associate mainly the origin of gems. The region of these rivers enjoys worldwide fame for its precious stones, a fame all the more deserved because it not only provided a large amount of valuable material for cutting, but also gave Russian mineralogical science one of its best pages, a description of the rarest precious stones of this Russian Brazil, as it was rightly called by academician Nikolai Ivanovich Koksharov. Our first night in the field. Tents are set up, tea is warmed, the day's worries are over. We are resting from the intense attention with which we followed the constant change of pictures. With the fast running of the car, the prospectors approached. Stories began of old booty, in which truth and fiction were intertwined, stories about the new life of prospectors, so unlike life in the old days. A quiet, warm evening descends, and with it comes sleep. In the morning we go to the Borisovsky Hills, a long-known deposit of blue kyanite. But only in our time has the industry paid attention to kyanite as a high-quality refractory. The Ural Institute of Applied Mineralogy carried out extensive exploration work here and calculated the reserves of this mineral. Kyanite was well known to all gold prospectors because its blue-like crystals are widely scattered throughout the plaza area. We walk along Sanarka and remember its former glory. This river was mentioned in Russian and foreign literature of the last century, in connection with the discovery of such rare minerals as euclase crystals. About 25 crystals were found here during gold panning. and each was valued at many hundreds of rubles. Only 2 places on the globe produce these minerals: the Sanaka River and the Minas Gerais in Brazil. Euclase, sometimes aptly called crunch due to its exceptionally pronounced cleavage, is really a precious stone, because it combines the beauty of color with clarity of tone and purity. It is such a rarity that it forces you to keep a strict record of every crystal found. With a strong glassy luster, its color is very diverse. There are crystals of bluish-green, yellowish-green color and even completely colorless. An even zonal coloration of the crystal is often observed, and usually the head is colored in a thicker tone, and the base is yellowish or completely colorless. Despite the variety of shades, Russian crystals are quite clearly divided into 2 groups in their color: greenish with a faint bluish, more often reddish light shade, and bluish-green, often of a very thick tone, of great beauty. Crystals of the first grade reach a larger size and are more elongated along the vertical axis, which gives them a resemblance to light beryls. Some thick blue crystals of euclase have long been mixed with kyanites, to which they are very similar in color, and it was in the batches of kyanite that the experienced eye of N.I. Koksharov managed to find the first crystal of euclase. In the 60s, interest in euclases was so great that the Yekaterinburg lapidary factory sent specialist officials to wash batches of kyanite in order to find euclase in it. We crossed the Sanaka River. It is all dug up and now flows in a small stream, then forms deep lakes overgrown with talcum, traces of ancient large mines. An experimental factory for washing kyanite was built on the shore, and a lot of material was brought from exploratory ditches. We sit down to the piles of material and select pieces of shale with kyanite crystals. Kyanite of the South Ural places has long been used for cutting, although Russian lapidaries were reluctant to take it up, due to the fact that the stone easily splits during grinding. In the places of the Sana system, there is a lot of kyanite in the form of crystals up to 4 centimeters long. Its color is unusually diverse, from pink or colorless to dark blue and green. Cornflower blue kyanites sometimes turn into sky blue or violet and, due to their transparency, undoubtedly have valuable qualities. Green varieties are no less interesting. Their crystals are usually smaller than blue ones, and their color is close to the color of aquamarine. They are also characterized by great clarity and transparency and can be cut. Kyanite crystals are usually strongly rounded, devoid of terminal edges, and often have a peculiar shape, thanks to which they receive the name oatmeal among the local population. They are mined during gold panning and remain in heavy stake along with other precious stones. We go again. The road goes uphill. A gentle long ascent, tall grasses. Hay mowers are working in the fields. Near the summit you can see exploratory pits and ditches. The dumps shine with mica leaves. The hills are composed of mica schists, in which kyanite is interspersed. Its origin is associated with processes of high pressures that turned aluminum-rich sedimentary rocks into mica schists with kyanite. For several hours we inspect numerous prospecting works, collect materials, and, loaded with a large catch, under the rays of the scorching sun, we descend again to Sanaka, taking to the right, to the old Andreevsky gold mine. Traces of major work are still preserved here. Grandiose excavations have been made in the limestone. Entire catacombs have been dug, the lower horizons of which are flooded with water, and bizarre passages lead from one cave to another. There was the richest gold, concentrated in a system of thin quartz veins in coarse-grained limestone. Now swifts nest in the rocks, filling the caves with cheerful chirping. Prospectors also came here and, following the traces of old work, they choose the remaining pillars. Later finds of lead luster, zinc blende, and excellent specimens of sinter-smithsonite zinc carbonate are also confined to these limestones. Their small nests have already been developed. but the area is still waiting for detailed scientific exploration. In the village, we meet a warm welcome. Drink tea with wonderful Ural wheat calyx. Ural wheat flour is one of the best in the world. Delicious strawberry jam and red melted milk. We load the collected minerals onto a passing horse and head to the quay, to our cars. After a short training camp, I would leave. Cars go quickly through the feather grass steppe. The horizon is wide. Villages are flashing, around which wheat fields are spread. It is a joy to look at these boundless fields. There are no stripes, all stripes they left with the plough. With a wretched horse and a squalid way of life, the boundaries of individual farms have been erased, and the collective owner of the field, the collective farm, can proudly look at the work of his hands and his machines. 2 hours later we drove up to Troitsk, a cozy, clean town. A short stop to buy bread and further south, along the railway track, to the Kartaly station, near which there is a large chromium iron mine, where one of the detachments of the South Ural expedition works. But the mine is still far away, and late in the evening we stop for the night outside the village of Krasnopolyanka. The evening is dark. We set up tents by the light of headlights on the bank of some river, boil tea on a Primus stove. The long day is over. Rest. Early in the morning it turns out that we are standing by a river overgrown with reeds. The docks are pulling. Our driver A.V. Babkin is a passionate hunter, abandoning his usual morning activities, snatching a gun from the case. He quickly disappears into the coastal tallow. The time of waiting for the result of the hunt drags on tediously. Finally, 2 shots in a row are heard in the distance. Flocks of ducks rise from the water, and after a short time, A.V. Babkin, wet to the waist, triumphantly brings a teal, and we listen to a fascinating story about swimming flocks of mallards, about cunning and guard birds, which we did not manage to get closer, and only one young, inexperienced teal fell victim to his carelessness. Successful hunting. Sometimes it was worse, either a misfire or a cartridge without a shot. Well, it's clear what just doesn't happen on the hunt. We arrive in the village of Poltavka, the district center. Here is the base of our detachment. With regret we learn from an employee of the detachment that the whole group of our workers went to another chrome region, beyond the Urals, to the Kraki deposit, located behind the Avsyanopetrovsky plant at a distance of 200 kilometers to the west in a straight line, to which a railway line is connected. A huge mine, many open-pit mines, mining sites. High quality ore is 38 to 40% chromium oxide. At the mine, we find the head of the mine, who kindly supervises the inspection of the mines. We meet a lot of young people here, students and young exploration geologists. With a large cheerful company, we inspect this wonderful deposit, discovered in 1930. The mineralogy of this mine is very complex, due to the fact that later processes caused a number of mechanical movements of the ore body, crushed and shattered the surrounding coils, and chemical factors processed these rocks and formed a number of rare and interesting minerals, completely unusual for chromium deposits in the Urals. We enthusiastically collect large beautiful specimens of green semi-opals, light yellowish chlorites, jeffreysites, violet chemerites and nickel minerals released when the coils were changed. We load the car and return to our headquarters in Poltavka after dark. According to the already established tradition, we set up tents for the night in the courtyard in the open air. In the morning we are back at the mine. On board the quarry, we choose a large typical piece of chromite for the museum, weighing more than 200 kilograms. We collect minerals, say goodbye to the entire mine. In Poltavka, we pack boxes with the collected minerals and hand them over to the base for shipment. End of the second part. Listen to the rest of this story on our channel. Also on our channel, you will find many other stories about expeditions and discoveries. Please subscribe and like our videos so that other people can know about them. Thank you very much. We work for you.